the way measurement's gonna work is, the easiest way of doing it is just to assume that you can look at any of the internal edges that you want. So if you have a big nasty fusion diagram, you can, let's see. Yeah, no, I mean, the way that they actually talk about doing it, like, basically, you can look at any combination of the fusion of any combination of these quasiparticles that you want. So basically, any of these internal edges you can just look at, and that'll be a projective measurement in the standard way. So you have alpha squared 0 plus beta. And the way this is actually implemented in practice is, you got a setup of, it's complicated. Often you set up some sort of electrical current going around the subset of anions or quasiparticles that you want to measure. And something about that current tells you whether the fusion channel is 0 or whether it fuses to 1. Which I can imagine.
So if you didn't know anything about like the top level 0 and 1s, like the ones at the leaves.
Yeah.
But the leaves have to be 1, right?
Huh?
Section.
Yeah, but
Then if you measure one of the qubits, that would tell you, right? If you do it, like in some ways, if you do it.
yeah, if you didn't know that this is a 0, 1, you can measure it.
You can measure a different one. Maybe you can find out whether that's a 0, 1, 2, right?
Wait, you can measure this and this, and that'll tell you this,
Yeah.
probably.
Yeah.
Well, if you get a 1 here and a 1 here, you don't actually know. Because this could be a 0 or 1.
Yeah, I guess it could.
If you had a 1 and a 0, then you know that.
Yeah, so there's some cases you know, some cases you don't know. Yeah. So that's measurement, that's braiding. Okay, so how do we simulate circuits? First, we encode everything into qubits, so this is what we often use in the Fibonacci model. We take 4 quasiparticles for 1 qubit. We just lie groups of these next to each other. The Ising model, again, 4 1/2 particles will give you 1 qubit, 0 or 1. That's fine. I mean, you could use more than 4 particles, in which case you get more than 1 qubit. Like for example,